The Comgrow T300 is a wonderful little 3D printer. I'm having a lot of fun and success printing with it. It has an annoying issue though, which I'm sure you also noticed maybe the very first time you turned it on. Yes, I'm talking about that unpleasant whiny fan noise, which is most noticeable in idle mode. There is an easy fix, however, that I will walk you through to make the printer quieter while still ensuring efficient cooling for the electronics. Before we dive in, take a listen. This is the noise before, and this is the improvement after. Notice how much quieter it is now. Of course, it will depend on the cooling fan you use. I installed an older 80mm CPU fan from a computer. I'm Gergo, and you're watching Gergo Print 3D, my YouTube channel dedicated to 3D printing and other DIY projects. It's been exactly 1 year since I posted my very first Sovol related 3D printing video, also on fan noise. So let's hear the difference. But that was for my first SV06 Plus. Big thanks to all of you who's been part of this incredible journey ever since. So today we are tackling the loud, inefficient blower by swapping it out with an 80 or 60mm fan, making our Comgrow T300 cooler and quieter simultaneously. The original idea comes from 3D Print Demon, who first replaced his fan in the original sheet metal cover, then designed his own replacement cover, which requires heatset inserts, screws, and multiple parts. I'll guide you through printing a more simple model to replace the metal bottom cover with a 3D printed solution featuring openings for your chosen cooling fan. This design is streamlined using minimal material and just 2 easily printable main components. You only need about 220 grams of PETG or PLA, a fan, and optionally a buck converter, which will be accessible for fan speed adjustments without removing the cover. Links to multiple fan and converter options on AliExpress in the description below. Yes, the printable model consists of 2 main parts, each printable in about 2 hours on our T300 itself. If you opt for a 12-volt fan, the usage of a converter is mandatory, of course, but even if you choose a 24-volt fan, I suggest adding a step-down converter for quieter operation. I recommend this LM2596 adjustable speed buck converter from AliExpress. You will see why. Start by printing the pieces, which you will find on Cults 3D, links also in the description. Feel free to reach out with any questions or customization requests. These have already gone through a few updates, and I'm happy to further improve the models. So first, we print the back half of the bottom cover and the little peg that will hold the buck converter. They fit together on the first build plate. I've included Orca Slicer projects for both PETG and PLA materials. By the way, I talk about my optimized T300 Orca presets in this video, which I will link at the end of this video as well. Note that the back half will need supports under this overlapping area, which should be removed before assembly. Then, print the front half that matches your fan choice. There are 3 options available currently, but I can add more later. You should disable supports for this front piece, however. The T300 has plenty part cooling for bridging the compartment's top and all the printable overhangs in this component. Before turning the printer off, remember to raise the gantry to 250mm or higher in preparation for flipping the T300 on its side. Then turn it off and unplug it too. Push the tool head all the way to the right and unplug the Z motor connection at the base of the right Z column and stuff this little piece of cable under the printer so it doesn't get squished. Important, when laying the printer on its side, the tool head should be off the table to avoid resting the weight of the printer on the X-axis mounting connection point. That's why we raised the gantry so high. With access to the bottom, we can now remove the 6 screws holding the sheet metal cover. Hang on to these screws, we will use them for the new covers. We now can see the electronics inside, the control board and the power supply. The dangerous parts are covered by an extra plexiglass, but still be careful around them. They can have voltage even unplugged. Originally, this tiny blower was responsible for cooling the board, simply by directing air onto the blue heat sinks over the motor drivers. Notice this blower is plugged into the header labeled VOU, not the one next to it marked fan. We unplug it, then we remove the 3 screws holding it in place. If your fan did not come with a JST 2.5 plug, you can repurpose the one on this blower. When cutting, however, make sure to leave enough slack to be able to revert to the original arrangement if needed. We will need to do a little soldering anyway, adding the buck converter. Just make sure the plug goes on the input and the fan on the output side of the converter, and the red wire is usually the positive lead. Use fan screws to secure the fan to the front piece. Thread the buck converter through its compartment, the adjustment screw facing the cutouts. This way it will be accessible from the outside. Use the little peg to hold the converter in place. Next, let's secure the back half of the bottom cover using the 2 screws towards the rear of the machine. Then we can connect the fan to the controller board. Remember, add the header marked VOU. And with this done, we can now secure the front half as well, sharing the middle 2 screw holes, holding both the front and back. There should be enough gap towards the front of the printer to route the screen cable along the new cover. With the covers attached, but before flipping the printer back on its base, let's plug it in and turn it on to check that the fan is spinning correctly. The adjustment screw remains accessible, allowing us to fine-tune the fan speed to achieve the desired balance between noise and cooling efficiency. Important, the fan is supposed to push the air out. The vent holes in the back are for air intake. See how this piece of tissue is sucked to the bottom as long as the fan is working? After turning on the printer, wait at least a minute before turning it off. We don't want to interrupt the boot sequence. Unplug the power before flipping the printer back on its base. Let's not forget to plug in the Z motor connection on the right. After turning on the printer, we can home the tool head to test every motor works correctly. After this whole procedure, you will want to redo the Z level calibration. For this, I recommend using my Z tilt via knob macro, which I introduced in this earlier video. I will link to it as well at the end of this video. During the first couple of prints after the upgrade, keep an eye on the host and MCU temperatures by adding these lines to your printer.cfg so they show up in your web interface. If they go near or beyond 50C, you should raise the voltage of the fan via the adjustment screw. You should be able to access it just by lifting the left half of the printer or the front, but then be careful not to crush the bad heating cable in the back. Thank you for joining in this little project. I hope it was fun and maybe even practical for you. Please help spreading the word by liking and subscribing for similar videos. If you haven't yet, I recommend watching one of these videos I mentioned earlier, or you know our motto, go print 3D. And let's keep the conversation going in the comments below. Take care.